science because we're more indebted to it. But I want to focus on just one simple point. Is it because science speaks the truth? Is it because science's relationship with truth is something special to the idea of science, which differentiates it from, for example, religion's association with truth, politics association with truth, and so on? Could this be the reason? I'm not saying that it is, but I want to, just reflect on this question. Could it be the reason? But if that is the case, then why is the idea of truth important? Why are they just not saying we listen to science because science knows how the coronavirus looks, and therefore, they know best what are all the kinds of medical issues surrounding that? So if I go back and look at the question of why is the idea of truth important at all, then as I said, we go back to a simple question: when do we even invoke the question of truth? And like in many of the examples I'll be using in my lecture, it's very simple. I'm going to talk about very common examples so that we are able to see the argument and the kind of ways of thinking about this, right? So if I'm sitting here and I see the table is in front of me, I talk about the table, the book is on the table and the water bottle is on the table. I do not keep invoking this question. It is true that the table is in front of me. It is true that the water bottle is on top of the table, which is in front of me, etc. We rarely actually use the term true in our daily transactions, and engagement and relationship with the physical world. I get out of my house, I know where to go, what to buy, how to move from one place to another, without every moment asking, is it true that this road is there here? Is it true that that bus is going to take me there, etc.? So there is a particular reason why this happens. And it is very well captured. It's somewhat misleading in English language when there seems to be a distinction between these terms here. Because in our common understanding of true, in our invocation of true, very often we talk about the true as real. The table is in front of me is exactly the same as saying it is true that the table is in front of me. Or to say it is true that the table is in front of me is to say that the table is real, it exists in front of me, I perceive the table in front of me. So there is a semantic space which is overlapping in the case of all the terms true, real, exist, perceived. And very interestingly, if you look at non-English usage of this, particularly in Indian languages, you find, particularly a derivative of Sanskrit, for example, that the word true and the real are both the common cognates. They come from the same root. And that's why you would say Satya and Sat are capture the questions of existence, real, and truth. And then there is no, you have to have other reasons to make a distinction between them. And in a sense, when we talk about the true, we are really working within this equation here: true equal to real equal to exist equal to perceive. We are actually working around it because in our common usage of truth, we invoke truth only when there is a conflict. When you tell me something which I don't see, which I don't accept, which I have not thought of, then we end up trying to invoke the idea of truth by saying what I am saying is the truth and what you're saying is not the truth. In other words, the idea of truth arises when there is a conflict, but in the conflict, I want to break it up into two parts. One, there could be a disagreement. We could have a disagreement on what I see before me. I could have a disagreement on, you say that there is an atom which makes up the table, and I am saying I just see the table, I don't see any atoms. So the disagreements can come because we hold different positions of things we see, or the disagreements can also come because, or the question of truth and conflict can come because you are talking about a world of unperceived entities, which I have no way of knowing. I have no way of experiencing. And when I'm saying I'm standing on, I'm speaking on behalf of all of those who are not part of your scientific community. So I'm trying to establish a kind of a debate between the science and the non-scientists by saying, well, I know when I'm going to invoke the question of truth. One, either I disagree with what you tell me, like scientists would disagree on the cultural descriptions of the cause of eclipse versus the scientific causes of eclipse. That's one kind of a disagreement. And the two, we could also disagree about the kind of objects you discuss and which you discover the whole world of the unperceived domain, which is not available to our common life. In other words, it's useful to think, instead of adding enormous amount of value to truth as if it is something very special, we can think about it still in terms of these connates of true, real existence, and as even as an adjudicator. And when there is something, and you can see this in the news, in the recent excessive discussions on fake news and truth and so on, there is the idea of truth is functioning as a way of judging two different positions or functioning as an adjudicator. But the basis of all this, there is the common link to why these kinds of debates happen is very old. It is one of the fundamental defining themes of philosophy. And in fact, as we know, science is very deeply indebted to philosophy, and philosophy is seen as a mother discipline from which various other disciplines come. And I'm saying this especially for students of science who may not know this. That, for example, Newton's was only referred to not as a scientist, which is a term which comes in early 19th century, but as a natural philosopher. So the status of philosophy and the kind of philosophy dealing with philosophy of nature, for example, were seen to be what captured the activity of science. But the theme, which was very common, which has been borrowed when philosophy breaks up into various other disciplines and when it engages with different kinds of human actions like science and art and music and sports and so on, the fundamental theme which underlies all of them is this tension between reality and appearance, based on a very simple observation which all of you know right from childhood, that what you see is not always what it is. And again, English is so interesting usage of the word "it" here. We don't know really what "it" is. You're saying, I know I'm seeing something. I know the world appears to me in a particular way, but I also know that there is a domain of reality behind it. So whether the domain of reality is genes and DNAs and molecules and atoms for scientists, or certain other kinds of categories for philosophers, or similarly certain kinds of aesthetic properties for artists, the constant theme which unites all of them is this constant attempt to find the reality behind appearance, the truth behind the appearance. And there is a very important lesson for us, other than this similarity between reality and truth, is that the simple act, and it's not unique to science, as I said, and science is unique in what it does with this question, but this struggle with discovering this domain of truth and the real behind a world of appearance, like in the very famous examples of Maya and Advaita, for example, is just one example of how these kinds of questions come about. The real struggle and the lesson from that kind of a struggle is very simple. That reality has to be discovered and cannot be taken as given. That what I perceive in the world, what I see around me, cannot be taken in its entirety as if it's given to me. In other words, anytime we talk about truth in science, then it is necessary to understand that there are two types of truths in a very broad sense. I'm using the type of truths again, but two different ways in which truth appears within science. One is, when I said discover reality, discover the domain of truth. That's what I mean by reality here. Like, for example, you discover the truth that this hard table in front of me is actually made up of, very ephemeral atomic and molecules, which atoms and molecules, which constitute this hard wooden thing called the table. And that's one kind of a discovery of reality, discovering the domain of truths, ranging from your quarks, the subatomic level, to black holes in the heavens. I mean, that's the whole range of things which are discovered at the level of existence. That when you say that it is true that there are molecules, what you're saying is, look, there are molecules. There are things called entities called molecules. There is an entity called black holes out somewhere up in the skies or whatever in the universe. So you discover that. But at the same time, what is very different and important for the idea of science is that the notion of truth is also created. And this creation of reality is very much a part of other human domains too. But in the case of science, you are able to create and synthesize. Chemistry is a very good example, other than technology and material science, etc., which are obvious examples, where the question of synthesis and creation of new molecules, new materials, new drugs, all add to the domain of truths of the universe. So suppose you create a new molecule which has not been done before. You have, in principle, what you have done is you have created a domain of reality, of a new reality of this new molecule, and that becomes true within the discourse of science. So this is very important, but the difference is also a very crucial difference between these two domains of truth related to science, and that is that created reality is largely material. I mean, for all purposes, it is material. It's things which you have done. Whereas discovering of reality, the truths of science, is actually far more complex. And I'll illustrate that by telling you very quickly about the types of truths in science. So that when people talk about saying, trust science, science is speaking the truth, etc., there is not just one view of truth in science. I want to show you, I mean, we could go much deeper into this, but just to give you an illustration of the kind of complexity of the question of truths within science which is present. One is the truths of instrumental perception. And this is the most important question which I'm sure every science student is encountering when they come to institutions like this, when you are exposed to very high-tech laboratories, very proficient scientists around you, you are recognizing that what they speak about is of a completely different world. It's an imagined world which is created in all complexity within laboratories, within instruments, within the way they write about it, and so on. It's a very complex construction of the reality of science which you encounter. And that is, instrumental perception is a core of what constitutes and what makes science so unique, which really differentiates it drastically from philosophy, for example, or from the other kinds of social sciences and so on. But the question about instrumental perception is what is the truth content of instrumental perception? How true is what I see through instruments? It could be the simplest example of a microscope or the example of a telescope. And I mean, we won't have time here, but I would just tell students who are interested, they should go back and look at when Galileo uses the telescope to talk about the moon and present his theories of the universe. It's actually very interesting because he is doing something in interpreting what he is seeing through the telescope. And the way he interprets it is not necessarily just scientific or follow scientific method. There's a lot of very interesting rhetorical uses which Galileo invokes in order to convince people that what you see through the telescope is indeed that particular object which is so far away from you. Or what you see through a microscope is indeed something which is there, a germ which is actually there. And today, when you extend it to atoms and so on, it's quite astounding for us to see how much we have moved in the way we have trusted science. Like every newspaper and TV channel shows the picture of a coronavirus, and I see everybody, whether they are science students or not science students, or old people or young people, who look at it and accept that picture of coronavirus and say, hey, this is how it looks. And when people show it with lights and sound, I wouldn't be surprised if many people think coronavirus has got all these colors and with all to go with all the shape and so on. And that's really about the trust one has invested in science, but it is also shows how science actually can manufacture truth and present it in very particular ways. But let me go to another kind of truth which keeps repeatedly occurring in part of scientific practice and scientific discourse, which is truth of patterns. And this is something really very interesting about this. Again, this time I'll come back to it a bit later, that you do discover patterns in universe in various ways. In fact, the use of mathematics, some philosophers would argue, is really a discovery of patterns. And good science and good data science, for example, are also discovery of patterns. And the question about patterns is, are those patterns really there in nature?
Sundar, we have lost your voice.
Chair is to the left of another, the description to the left of is added by me. There is nothing in the world which might actually tell you that an object is to the left of another object. And so our descriptions, our discoveries of those truths, and this is a fundamental question, I would say, about science and in the philosophy of science, which is the world as described by science through human cognition, through human intelligence, is it completely independent of human subjective position? Yeah, again, a point which is very wonderfully described with Heisenberg, one of our founders of quantum theory, in a book which he writes on idea of reality. It's a book on philosophy, on notions of what he means by real, and he's invoking this question, this fundamental question, which I think all as philosophy students, most of you would know. It is really about understanding the role of the human subject in describing the world around us. And that is a question which comes when we talk about truth of patterns. There is also a domain of truth which attaches itself to science, which is through the use of technology. And it is actually something which is very simple, interesting, and used across domains, not just in science. It can be used in medical, in Ayurveda, in homeopathy, etc. It is used in many of the kinds of crafts, craft works and so on, which is that if something works, you can infer that something is there. So let me give you a simple example. We could, we could go on discussing whether electrons are real or not. Do they really exist? I mean, are they really like what the physicists tell us, and so on? But a quick answer to all that would be to say, hey, look, you are watching a TV, and what you see, the images in the TV is due to an electron, and this is what the philosopher of science Ian Hacking famously calls as, if you can spray them, then they are real, they exist. Which is, if you can do something with them, then you have shown their existence. You don't have to really get into a huge argument about whether electrons exist, because it says, because electrons exist, I build a TV knowing that these are properties of the TV. Now, while this might seem like a very powerful argument, we have to be very careful, because while it is true that my TV is running because I hold certain positions about electrons and so on, we should also recognize that the fact that a TV is working or doing what it does is not just because of the existence of something called electron, but a whole host of other truths around the idea of an electron. So I'll come back to it later and see how that causes a unique problem for truths of science. Typically, from the old philosophical discussions on truth, one of the ways by which truth gets associated with in science is one which is defined through correspondence, which is you call anything as true if it corresponds to the word. So when I say the table, it's true that the table is blue in color, then what I presumably am saying is that it is indeed the case that there is a table in the world in front of me which is blue in color. So my truth is just a statement of something which exists in the world. There's a correspondence. Truth gives you a bridge between our cognition and the world which is outside us, which matches what we say about the world. It's a very powerful idea of the correspondence theories of truth, but all of science does not adhere to that. While we may want to believe that scientific truths are actually correspondence with the world, that there is indeed really something called an electron, that there are indeed some things called, electron functions, both like wave and particle and so on. But that is far more, it becomes far more complicated, because the fact that these kinds of descriptions of an electron
We can't hear you, Professor Sarukkai.
Sundar, your voice is not coming up.
Through concepts, through the use of mathematics, for example, in physics, and so on. And the fundamental rule of coherence is the notion of consistency. And that's a very important idea of truth as arising through coherence. And one could also argue that many of the examples of truth in science are not just about, it's difficult to show the correspondence, but they could be through notions of coherence. There is also another species of truth which is so important to science, but it is also so different from science. And that is a species of mathematical truth. And that is sufficiently interesting that I will speak a little bit about it separately. Okay, because mathematical truths seem to be so special to science, but they're also very different from the way we understand truths in science. So just to give you, therefore, a kind of a summary and a list of things we have talked about. If you ask me what is a domain of truth, what are the kinds of things we want to assert as being true in the world, it could range from subatomic, like I said, atom, quarks, etc., to black holes. I mentioned black holes again because of the recent Nobel Prize for work done on that. It could range, I'm just using the examples of subatomic, but there are very complex kinds of structures which are present, both macroscopic, microscopic, engineered, non-engineered, etc., all of which you would want to assume as being true in the world. But what is also interesting to the idea of truth in science is it is not just about naming some objects like atoms and quarks, etc., which exist, or DNA and genes. Science invests enormously in the reality and the truth of properties. In fact, one could make the argument that objects per se are not as important to science as properties are. And the discussion, that relationship between properties and objects is actually a philosophical discussion which science has very happily moved away from. When it moves away from what it calls as metaphysics and its complete dissatisfaction with what philosophy was doing, then it's moving away from this question of whether properties constitute an object or not. Just to give you a very quick example so you understand the significance of this. So I have a table in front of me. I perceive the table through various properties, through qualities of the table. I see the shape of the table. I can see the color of the table. I can touch it. I can feel how it feels to my hand. I can maybe taste it if it has a taste and so on. But my perception of the table, my experience with the table is only through these senses. I do not ever experience the table as such. All I can say is, why do I know there is a table? Because I see the color, because I see the shape, because I touch it. I'm not touching the table. I'm only seeing its color, seeing a shape and so on. So this question, as I said, is a very old philosophical question, whether all the qualities create a new object or whether we put the idea of an object to these things. So science has stayed far away from it, but invests a lot in the truth of properties. In fact, that becomes the most important characteristic of how modern science is possible, like when Newton is able to conceptualize a question of center of mass and is able to reduce huge masses of the universe, including the sun and the earth, as points on which to do some geometry around the earth going around the sun. A remarkable kind of an imaginative, creative enterprise, which really, which at its base is philosophically nothing more than an emphasis on the reality and the truth of properties. And what is special to science is it creates properties which is not present in any other domain of human activity. I mean, I'm just using the examples of charge, spin, etc. But almost every property you come across in physics or in chemistry and biology are very unique properties whose truth is central to a core idea of how the scientific discourse is actually built. So, but there is a very interesting spin to this, if I might use the word here. It is that the properties which science talks about, the properties which define the way you build your theories of science, are primarily measurable properties. You will not obviously see the property of color here or what are called secondary qualities, taste, for example. These are only measurable properties, something which goes back very often to Galileo and his idea that to do science is to just describe nature in terms of measurable properties. There are other kinds of domains of truths in science. For example, the whole domain of mathematical objects, numbers, functions, sets, any, I mean, you can, your groups and whatever, and within groups, 100 types of groups and so on. So you have a huge number of objects present within mathematics. And there is a very interesting question. Is there something true about them? Are they all true? Or what does it mean to talk about that? Then you have laws of nature essential to physics, particularly physics, much less to chemistry and biology. But in foundational structures of science from physics, we recognize that laws of nature are one of the most important, aims of building, of doing physics. That is, physics is engaged with discovering laws of nature. And laws of nature are supposed to be true of nature. But one of the most interesting philosophical questions is, what does it mean to say laws of nature are true? What is true about laws of nature? Are there laws which nature has written, which all objects have to follow? And if so, who is enforcing it? What kind of an agency does nature have to enforce that two objects should indeed obey Newton's law of gravitation? It's quite a remarkable idea which you should think a lot about. Feynman, when in his book on nature of scientific laws, talks about laws of nature as governing nature and so on. Very problematical invocations of idea of somebody running the way the objects function in the world and so on. But for most of science students and the people who do science, we tend to use laws of nature as if they are true of nature. But that itself is a very interesting question which philosophers and historians of science have shown is far more complex than just saying there are laws of nature and they are true in nature, and the task of physics is to discover what they are. Similarly, and I'm not going to go further about it, you could ask the same questions of
Your voice is not audible.
ordering it according to our cognitive structures and our linguistic structures. So is it that we are using these kinds of, we are imposing these kinds of concepts onto nature, or is it that nature really has these concepts? Is it true of nature? Or is it just a correct application of human thought on nature? If it's a central question, I think, really any discussion and thinking of science has to begin at that level. All I'm trying to say with this example is that we have to recognize that when you say that trust science, science is speaking the truth, we have to recognize that truth has many different levels. So the chair, it is true that there is a chair in front of me, but it's also true from scientific description that the chair is made up of molecules which I cannot see. So at different levels, I'm using the word levels very loosely here, there are different types of truths present in the world. So when you say scientific truth is very important, we just have to take heed of this. We just have to be careful that we recognize that there could be truths which are being articulated by others. It may be doing something completely different. It doesn't mean they're false, but it may not be as in depth as what the scientists might say. It may not be as complex as what the scientists might say, and so on. But the point is, it's not easy. I think as some people tend to do, to think as if the domain of truths exists only in science, we would be making a major mistake in doing that. And I'm just illustrating with a simple example. And the question of mathematics and science complicates the idea of truths in science to a great detail. Because at least, given my old avatar of doing physics, so I am more inclined towards looking at the question of physics, of course. But, this larger truth about mathematics and the relationship to science is far more complex other than just the question of physics. But what is so interesting about mathematical truths is that mathematical truths become the model for truths. But what is interesting about them is mathematical truths are completely independent of the world. And for those of us who think that we are modeling the world through mathematics and therefore it must be true, we have to stop a moment and ask, why should it be true? Because mathematics is quite indifferent to how the nature, the truths, the empirical truths of our world is. You could have used the same, suppose you had, let's say, Earth and anti-Earth, where everything is opposite of Earth. So I drop a stone, it goes up rather than falling down. Then you would still use the same mathematics. Mathematics doesn't care whether it's on Earth or it's on anti-Earth. Because all it will do for Newton's law is it might write F equal to minus g m1 m2 by r squared rather than F equal to g m1 m2 by r squared. That's enough. Such a simple thing can immediately change the ways in which we understand the empirical world. So what is it about the nature of mathematical truth, which functions as a model of truth, by the way, especially in Western science and Western philosophy? It is mathematics which is a model for Western philosophical thought, unlike Indian philosophy. So how much this idea, that notion of truth in science, attempts to constantly reach the idea of mathematical truth is something we need to think about. And today, when kinds of computer visualization, data analysis, producing, we produce science today in terms of very effective pictures. And what are the truths of them? How do we understand the kinds of truths of them? I wanted to, okay, I'll just do it very quickly here because it's just a simple example to illustrate that why the idea of true itself is so complex. Because as I said, even in the simplest examples you can do it. So more complex examples is more easy. So if I just have a sentence like saying stone is falling is true, of course we know. And saying a statement stone is falling with an acceleration of something is also true. Stone is falling under force of gravity is also true. So I have already three descriptions of truth of a simple phenomenon of a stone falling. I could also have a statement, stone is creating some sound as it is falling. Some people may hear it as music. That is also true. So what is it that we are looking at when we say that scientific description is true, but other descriptions are not true? What is it? What is it that drives that point? The first point to note about this is that there are two problems with this. One is that you can never give a statement of truth, like stone is falling, in itself, by itself. So 2 points. Each of the true statements I gave you before depends on other assumptions. So I could say stone is falling is true, is correct, but only if you are not falling with the stone. If you're also falling and the stone is also falling, all this question about relativity and so on. Very interesting questions which it raises. So there are many such cases, what some people call as ceteris paribus, under certain conditions. Every utterance of truth is under certain conditions. This is a very interesting way of understanding any truths you say, anything, whether electron has one unit negative charge, etc. Any statement which you say as being true is only possible under certain cases. So acceleration value is true, but if there is various other kinds of systems around it, including a kind of an idealization of the object, force of gravity is true, etc., and so on. Okay, so I'm just skipping here because all I want to tell you, the main point I'm saying from all this is this sentence here, that a truth in any subject, it's not just about science or philosophy or social science or anything of that kind, or in art. A truth is always in a web of relationship with other truths. So when you assert that this is true and this is what I want to follow, you are actually carrying a whole baggage of other elements associated with that truth. So it makes the question of truth far more interesting in various ways. So
Sundar, your sound is gone, I think.
.5 lakhs of papers were published in 2018, and more that is, if you really look at it, it's about 7,000 published papers every day across very, of course, sub-disciplines. But you should remember that the number of papers that are published are a fraction of the numbers which are written. It can range anywhere between 5 to 25% depending on the kind of journals you send it to. Which means if 7,000 papers are published every day, which means nearly, let's say, 30,000 papers are being submitted, and the others are all being rejected. It's an enormous amount of production. And remember that every paper which is published has to have something new in it. And there is a Nature article which points out that 2 papers are put into the PubMed database every minute. And they also point out that if you look at the total amount of science, what you call as science, scientific knowledge, scientific production in all the different disciplines or in the history of humankind, or at least of modern science, recorded modern science, then in the next 9 years, we'll be doubling the entire scientific output of all these years. What is this? Is this that every paper, remember, that has to produce something new, maybe something, they must be true, of course, otherwise they're not going to be published, I presume. And therefore, you're producing, Avala is a tsunami of truth, to the extent that, as many of you may know this better than I do, that scientists today have curators. That is, curators who, choose which articles they should read, because they've all lost control of the number of things that are being written and published and so on. So this is a very important question. What it is asking is science really about truth now, or has it changed drastically? And it's definitely changed very drastically, as illustrated by the 2019 Google Scholars list of the most highly cited publications. Out of the 7 most highly cited publications, out of the top 5, 3 are in AI. Out of 7, 4 are in AI, and the other 2, for whatever reasons, are on obesity. And the most cited paper in this list of the Google citation 2019 was a paper written by a Microsoft research team, not by our traditional research groups within universities or scientific research institutes. It has completely changed the way in which we understand science, because today science a large of science, both in terms of money and in terms of production and in creating reality. Like I told you, the new domain of truth which science creates are coming from AI labs, pharmaceutical industry and chemical industry. And the question you're really asking is what kind of a science is that? What is the relationship between truth and the kind of science which is being produced in this massive scale? And many people are suggesting that it is this privatization of science which is going to become very dominant in the coming years. We have today labs which are run by robots and AI, and really graduate student, PhD students are going to become expendable very soon. I don't mean it too seriously. So, but it's going to happen. Then what is the nature of truth produced through all these practices? And that's a question which leads me actually to ask about the nature of science. Because, the reason I'm saying this very briefly, and I'll end with these few points for the next 5-10 minutes, is that, the reason I even thought about conceptualizing this debate or this discussion or this lecture around the question of truth is because of a fundamental problem we have all been facing in India. And it's an extremely important problem which has repercussions on the practice of science, the running of science, as well as, about the very education system within the country. The question is very simple. On the one hand, you have a very powerful domain, a very powerful institution called science. Although scientists keep saying that the government is not supporting them, etc., etc. But let me tell you, from people who have been completely marginalized by the government and others in the country and elsewhere, humanities first and then the social sciences. So, we don't understand that at all, but I can, sympathize with it and say, okay, I grant you that. But the larger question is this, something which should worry every science student and every science teacher. It is this, that in every country which has a very good index of science, who do science very well, who have had great impact of their scientific work, they have also had very good quality, independently funded, collaborative humanities and social science departments, particularly institutions of science and technology studies. In India, we don't have one science and technology studies institute. We don't, for various reasons, if there are any questions, we'll talk about it. So I want to talk about the distinction between the way truth is constructed in science and the way you discover truths about science. So just like scientists discover truths about nature, some other people from different disciplines discover truths about the practice of science. And I think it's very important for us, also because of my interest, but I think because as a national goal or whatever, it's very important to understand that it is necessary to study science. It is necessary to study science, not to convert everybody into doing social science and humanities of science related to science. It is necessary to study science for doing better science. One of the best examples comes from the very fertile production of science with the quantum theory in the early 20th century, work in relativity, quantum theory by Germans, French, and the British scientists and Russians to some extent, where for many of the particularly the German scientists, including Einstein, Planck, and so many others, they were all trained in different subjects, including philosophy. Einstein held the first philosophy of science chair. The point is that the doing of science, the understanding of science through a larger framework was seen to be very essential to producing better science as a community, as a group, as a nation, etc. Second point, why do we study science? Because science, especially in places like India, is largely public driven, in the sense it's funded by the public, it is funded by the government, and therefore questions of accountability, sharing of resources, all of that come about. And that's one reason why we study science. And the final reason, not a final reason, one more reason which matters a lot to me is to have some idea, to have some control on the future of the world, because the way in which science and technology is influencing the progress of the world, is influencing the way we think about everything. Now, it's not just about the physical world. Our cell phones have changed personal relationships to such a great extent, have changed the structure of social relations to a great extent. So we are concerned about the future of the world as citizens of the world. And the scientific community is such a small community, a fraction of the world's community, which seems to have disproportionate amount of power in shaping our future. So we are worried, or we want to have a say, or other communities want to say, hey, is there some way in which I can engage? It's actually a question of power, and how we engage is a question of power. So for all these reasons and many more, we should study science. But then it raises a question, who should study science? Should it be scientists who study science? And in the Indian case, for the last so many years, and Prof. Homeopathy can also attest to it because he's been part of many of these discussions, it's a very big challenge because there are scientists, scientists know best about science. I don't think, we are going to quibble about that. They know best about doing science. But does it mean that they know best about the history of scientific ideas? Do they do work like historians of science do, meticulously looking at records kept by scientists, meticulously looking at archival records, looking at the letters and diaries they write, seeing how that idea came about, what inspired them, etc. Or about philosophers of science who try to understand the conceptual basis of what science is, or sociologists of science who do this very important task of trying to understand how does science grow in relation to the growth of a society. What is the relationship between a culture of a larger society and the culture of scientific institutes, for example? And many such questions of things which they talk about. So who should study science? So my common example I often give is that we all speak language comparatively well. All of you, I'm sure, can read and write very well. But definitely linguists who do what is called science of language, know something more about science of language than all of us who are very good practitioners of language can do. Scientists are good practitioners of science, but sometimes you do need, many times, especially now that science is a social product, you need other people to look at it. And therefore, it leads to the question of how to study science today, and what I call as the history, philosophy, and sociology of science plays a very important role in it. I think we should remember this. I'm saying this also in the context of a science institute. Like many of our science institutes like IITs and IISERs, which have been, I think, especially IISERs have been a great revolution. And I know that, good leadership is very important, and they probably can shape and change the kind of vision that you can have. And I'm really hoping that, IISER Bhopal is going to be one such. The point is that in all these institutions, there is a conflict, there is a fundamental tension between the positioning of the humanities and social science departments within a science institute. And I know this, it's been there for years. And I was a student at IIT Madras when I did my physics. And there the humanities and social science department was the one which was most looked down upon. It's been there forever and it will continue. And it's very odd because humanities and social science departments are autonomous. They are producing knowledge about very important things about the society in which science is placed. And still it happens across these institutions, because I know some of them very well from the inside, from what is happening, that you would still have scientists deciding on the kind of work or the kind of people who will be in humanities and social science departments, or kind of work which they should be doing. And that, I think, reflects actually on the national part of quality of science, and it also impacts on the students, because the students of science, I find, are the ones who would most appreciate a great exposure to the multiplicity, whether it's a course on music or a course on poetry and a course on philosophy or history, really empowers them and makes them very thoughtful scientists, which is good for everybody, and it's good for the quality of science. So the reason I'm saying all this is why this diversity of views on science is needed is because science is not just about doing something in the lab or solving some equation. It's a creative enterprise. Scientists, for people who try and reduce science to logic and method, I feel bad for them, because they miss the fact that science is very creative. You are like artists when you do some things. Completely, nobody knows why you have done something. It's really remarkable. Then you do other things with it. Science is a very creative enterprise. It's completely historically and socially situated. There is no science independent of the historical trajectory, including, for example, your own institutions or any institutions in India which have come through for particular historical and social reasons. They are linked to the global, they are very deeply related to military and finance, and fundamentally it is a social practice in which many questions of gender, caste, class are very deeply involved. So when I want to talk about the truths about science, and when scientists say that because they are doing science and science is a very close connection with truth, that somehow they're insulated from these studies, then we need to ask the question, what is the nature of truths in science versus what is the nature of truths about science? And I'm just going to end with the last slide here, just to point out certain specific questions in the Indian context, just so that you open up this question about how to look at this question of science through these complex disciplinary matrices in order to, as I said, produce a better culture of doing science in India. The caste and class question is an extremely important question. There is no way we can escape that. In fact, one of the strengths of science comes from its presumed democratization, in which where it broke the class barrier. And it's particularly true in Britain, for example, where class hierarchies were very rigid, that it was a kind of a movement across class, which science made possible. In India, the question is not just about class, which we do very badly in, but also about caste. And the reason how caste and class enters into your science, into your classrooms, into your laboratories, into your textbooks, is because there are very specific notions of merit and privilege of certain types of knowledge, which are even used before you're chosen into these institutions where you do science. And I'm sure all of you are aware that while all of you who have passed this exam, who are in all these institutions, are obviously very bright and a great hope for the future, you should also remember, I think, and knowing enormous number of excellent students, very good students who I think would have become great scientists, but do not get into these institutions for various reasons, including very vague, very complex and I think very problematical ideas of questions of merit and what kind of merit one should have to do science. And in this, I'm just reminded of the golden period of Indian science and technology, where some of the greatest contributions in Indian science and technology came about, including in mathematics, including in technology, chemistry, medicine, and so on. And if you look at the famous example of metallurgy, of steel making, zinc making, etc., who are the people who are doing it? They were not the privileged caste, they are not the dominant caste, they are not the upper castes. It was a far more egality. The people who are blacksmiths, who are doing from very many different caste labor practices, were actually producing some of the world's greatest technologies of that time. I mean, we were the Harvard and Princeton where people would have to come and learn from people here. What does it say about the idea of science, and what does it say about the democratic access to the kind of people who have great skills with the hand, who can produce great experimental work in India, but who cannot because they cannot crack through our great exams of a particular kind, or they cannot even enter our schools and pass through our schools in a particular way? What is the responsibility of the science community towards this? This is one way of asking that question. The gender question is as troubling as the caste question. And the gender question is a global question. The question of whether women can do science, whether women should
We
social
can't hear
question.
you.
Oh, you can't hear me? Okay, I hope it's not because I started on the gender question. Sorry.
It's audible now. Yeah.
Okay,
Without
yeah, okay, sorry.
questions,
Yeah. No, at the right time, we didn't cast class in gender yet, Anyway, no, I'm just saying this as all I'm saying is, what kind of disciplinary training does one need in order to understand the relationship of caste, class, and gender and creativity in science with the practice of science? Who can therefore do this question very well? So when we understand that, in the part of the question of who should be studying science in India and how do we study science in India? So this is I'm just giving you this particular example as an illustration of it. And the root of the problem is that science is a social institution, but unfortunately, many scientists act as if it's asocial. There is a lot within scientific discourse which presents itself as asocial. That it does not matter whether Newton discovered laws of motion, because that's laws of motion is of the world. It doesn't matter what time it was discovered, etc. There's a very, very interesting philosophical questioning around this idea that how does science present itself as asocial while it is inherently very social. One of the ways by which we have studied this is, as I said, through the matrices of history, philosophy, and sociology of science. People who do literature have done, and it's not just about studying science, it's by looking at the link between science and society and so on. For example, gender, class, caste. I mean, there are many of these questions really have to function with a very a good ecology, a very good environment in which ideas flourish, independent of whether they are all doing some science or physics or chemistry or maths or biology, etc. And that is a spirit in which some of the best departments in the world, which if these universities are a model for us, then we should be asking why, if you model yourself on the science departments at Harvard, for example, then we should also recognize that they have one of the world's most important history of science program, or science and technology studies program, or philosophy of science program, or literature program. So what is it about these kinds of, this kind of interdisciplinary thinking and sharing of ideas, which I think, as Professor Homeopathy would know, is a very important part of, the Indian Institute of Science, the kind of culture within various scientists and others who have had this possibility of, cross-pollinating ideas across domains. So this is just a plea for trying to see how we are going to engage with these in our science institutes, because the basic point is the truths about science are historical, philosophical, and sociological truths. They are different from truths of nature. And my final point in this, I want to end with this, is that many times, and it has happened to me hundreds of times, it has happened to so many of my students and colleagues who are in these fields of history, philosophy, and sociology of science. Typically, scientists tend to think of our work as being anti-science. But when scientists say that the law of gravitation is 1/r² and not 1/r³, they are not being anti-nature. They are searching for the truths of nature. And when they say it's 1/r², they have good reasons for saying it. But whenever we talk of history, philosophy, social science, the first response of the science community has been that, oh, they are criticizing science or they're anti-science. It's never the case. All that we try and do is to understand the different kind of questions, different levels of reality, different levels of truths about those fundamental assumptions and foundations on which science is built. Thank you so much.
Thank you, Professor Sarukkai, for that wonderful and very, very rich talk on science, the hold that modern science has on us, on society, because of its claims to truth, different kinds of truth. So, whole range of and wealth of ideas for us to think about here, different kinds of truths in different domains of the sciences, mathematical truths, truths about data, and truths in the other scientific disciplines. Then very important takeaways I felt in the talk. One is that truth is in a web of relations with other truths. And also several points that you made towards the end of the talk about the role of the humanities and social sciences in, so a lot of these of course speak to us, and the need to do science, who does science, and the need to do science or understand science from various perspectives, including sociologists and other philosophers of science. So science, again, is a social institution, as you say, unlike the conception of science as being asocial by lots of scientists. And very importantly, I felt kind of the way in which you pointed out the need for multiplicity, cross-pollination of ideas, and the ways in which science is implicated within and situated within social relationships, really, like of caste, gender, class, and so on. So thank you for that really rich talk, and I think we have lots of questions, so I think I will take some questions now and relay them to you without speaking any further. So I will compile some questions and put them to you. So there is a question from Sarthak, who is asking about the inherent biases within practices of science. So most of what we imagine comes from data, is also inheres biases. That's what he's saying, and personal preferences. So how do we conceive of objective truth? I think that's what
actually I can see that. I think a couple of other questions also
yes
have to do with this. So let me try and connect a couple of them so that
okay.
they're on similar stuff on
So
bias
another,
and so we're going to get any truth objectively. The question is this, that we need to really understand the very invocation of the word objective, and when does it become very prominent in the sciences. And that's actually a much later development in the history of science, the very word objective. Look at this very good, interesting work by Lorraine Daston and Peter Gallison on the history of objectivity in sciences. Because the earlier meaning of objective was not at all what we call as objective today. But the fundamental question here, we don't have to call it philosophical, scientific. Anybody who's thinking about it will have to ask this question, which is that how much can you remove, or how much can you guarantee that the human presence is not influencing our descriptions of the world? And it's very true that, you know, if we had different visual structure, we would see the world differently. And if we have, you know, maybe more eyes, or eyes are very differently powered, we would actually be seeing something very different. I remember reading in a book on history of ideas, that one of the authors is saying, perhaps half in joke, that if we had had eyes like, let's say, some of the insects, we would have actually seen the curvature of space, and we didn't need Einstein's theory to tell us space was curved. You know, something like that. So that means we are working to the limitations of our concept, cognitive structures. We are also working with the limitations of our instrumental structures. So I think the question of objective here should be read in a much larger sense, which is that for all humans, that's the first step. The first step is we don't know whether the dogs are going to see this differently, whether dogs are going to have other concepts to describe the world in and solve some other equations, right? But maybe they do, maybe they don't. But for given the universal biological human structure, and that itself is a very scientific way of looking at the body, there are certain common patterns, common understanding, common experiences that we can get, and that is all that we can aspire to in terms of this. But I must also add that the very idea of scientific method is one which is nothing more than the removal, an attempt to remove the human subject from our descriptions in science. That is all that the scientific method is. For example, verification, falsification, you know, doing whatever you think you do as part of science method is nothing more than saying, recognizing that we may probably be influencing the description. How do I find a method to remove our influence in the description of the world? That's all. So, so I think we need to relook at questions of what is bias in the question of the subject, but that of course is something which philosophy of science and other philosophy itself would have been looking at, very closely.
So there was a related question, I think, about secondary qualities and constancy. And so if somebody sees the color red, then is it the same color red that somebody else perceives? And
so one of the ways by which this question of scientific method takes care of it, like in the example of Galileo, is to say that science will only talk about qualities which are measurable. And in some way, the question of measurability, question of quantitative methods, which influences social science so much today that forget about science, which at least is not really talking about personal experiences, but in social science, you may be dealing with the social problem of, let's say, since there's a question of manual scavenging, I can use an example, and like we know in all our study of caste, questions of experience of manual scavenging or poverty in India, you would still have very quantitative methods to grapple with that problem. Because there is so much of suspicion about the idea that human qualities are very special to individuals and they are not transferable across. And somehow the measures, giving a number, seems to bring all of us together on that track. So I think, again, I think we should also remember that science has changed so much. And I keep coming back to the point that the kinds of science which is being done now, particularly with the computer, digital visualization techniques and big data, it's a completely different kinds of questions we need to be looking at. I think the traditional questions of science or philosophy of science really are not going to be very helpful here because, even the question of experience, secondary qualities, notions of those kinds of seemingly human qualities are very much a part of this complete virtual reality, artificial intelligence type of a digital world that we have been creating. So the creation of science has become far more dominant than the discovery of science in particular ways.
So there are a couple of questions about philosophy of science, the discipline of philosophy of science. So there's one question from Ivan, which asks, is it philosophy of science or should it be called philosophy for science? Are most philosophers actually philosophizing about the practice and assumptions about science or performing philosophy to justify already accepted assumptions of
Yeah.
science. And
Okay,
there's
I
one
think, yeah,
more, I
yeah.
think, about, yeah, so there's one more from Vatsala. Do science philosophers study the implications of science by looking at the past and the purpose of that research, or is there more to it?
Yeah. Okay. So, there are, like with different branches of science, there are different branches of philosophy of science. And what Ivan is saying is very true, and particularly true in India. There's a growing group of people who think, I call them the cheerleaders for science, which is good, but I mean, that's what they think they should be doing. But I really think it's, not the kind of task which philosophy had set itself upon to do when it does something called philosophy of science, for example. So you are very right in that people think that there are some philosophers should only try and describe or support what scientists are doing in particular ways. But it's also part of a particular tradition within philosophy of science, either from the analytical tradition or from a particular tradition of philosophy of science who think that they should be doing some kind of a science come philosophy. It goes back to a very important question: who should actually be doing philosophy of science? A point which has single-handedly, I must say, stopped the establishment of good master's programs in philosophy of science. I remember over 30 years ago, in the early 90s, nearly 30 years, we had a meeting with people in Jadavpur with the philosophy department. They had a very good philosophy department. People like Professor P.K. Mukhopadhyay and others were there. And
Yeah, we've lost your voice again. Professor Sarukkai, we've lost your voice.
people were, every time we talked about it, people would say, should science students do it or should only philosophy students do it? So one of the semi-science guy who was interested in this told us that, a science student can understand Kant in 2 days, but a philosophy student will never understand theory of relativity. So you cannot do philosophy of science for these guys. I mean, that kind of a completely warped understanding of science has really played a havoc with our ideas of philosophy of science in the country. And today, the worst part of it is you do other kinds of philosophy of science, for example, which could be, for example, socially sensitive, which could be political in nature, etc. Then you often get pulled into various politics of other people's concern about how they've been using science. And I got caught in one of them when I wrote this piece on March for Science, criticizing very naive ideas of what some of the scientists were doing. And it was worse than getting trolled by the right-wing people. So it's so what I'm saying is it's a genuine problem we need to keep looking at. But the way I do philosophy of science is very simple. I think for me, it is just that I have a problem which I don't understand. I want to make sense of it. I want to see how I can resolve that problem by drawing on any philosophical tradition, or maybe sociology, maybe history, in order to make sense of it. So, yeah.
So yeah, we have lots of questions flowing in now. So I think we'll have to select a few. We wouldn't be able to take all. So there's one question from Chinmay, who is asking about theories in linguistics.
Okay.
When we think of external reality of linguistic descriptions, we come to see that the reality or ontology of grammatical categories is rather based on the theoretical epistemological categories. So it is not the case that adjectives exist, but it is because of the theory that constructs or doesn't construct adjective as a theoretical category. If this is so, then we are back to idealism versus realism. So truths of language are always in relation to the methods and commitments of linguistic theories.
Yeah.
And truth of language is theory dependent. So
Yeah.
he's asking, can there be theory independent truth of language?
Okay, very interesting, difficult question. One quick answer to that is one of my students' thesis, job in Matthew, he wrote his thesis on is linguistics a science, and discussed many of the questions on uh, what kind of categories of science can really be mapped onto linguistics and so on. But I think Chinmay's question has a larger uh, resonance with a very important question in philosophy of science, which is the larger theory ladenness. So whether it is about adjectives or whether it is about, let's say, electron or the negative charge of an electron, the question is that since we believe that science is supported by evidence of whatever experiments and observation, then there's a very genuine problem whether what we see as observation or what the data that we see in the world, is it influenced by the theory we already hold while we go searching for that particular data. And there are very simple examples to illustrate that very well. And that has been very strongly resisted because that seems to drive a circularity. And as Sinma correctly says, some variations of the idealism debate, or at least the subjective debate in some sense, that you can never get out of. You can never make something completely mind independent declaration about the world. Now, while that may be true, I still think one of the ways of responding to theory ladenness or the theory influence on data is to look at different kinds of theories and different kinds of observations and so on. So it's a particular method to try and resolve this problem, but at a very deep problem, I would say that this question of theory independence to me is still open, because it goes back to the question of what constitutes theory. If theory comes with specific connection to language itself and not just so-called formal logical structures, then you're using language to excavate language, to excavate the nature of language, and that leads to a very interesting epistemological question. But on the other hand, I would also suggest that ways of approaching the questions of language through subjective experiential accounts completely gives us a very different way to understanding, so-called quote unquote truths of language. And very quickly, with something which you might know better, is to look at theories of music, particularly theories of music in Indian tradition, in Indian classical music, of many of these traditions of the very ancient texts. Phenomenally interesting questions of what constitutes language, either from the grammarians like Bhartrhari or the Natya Shastra, Sangeet Ratnakara, etc. What constitutes music, and the question of truth in sound and language which are present. I think that we have some kind of an approach to that which might be of interest to some.
So I think we are running out of time here. So I think I will restrict it to two more questions probably. So there is one question from YouTube. Let us take one question from YouTube. So there are several questions there, but I'll just choose one. So Soumya is asking about homeopathy, and says that there is not enough evidence that homeopathy works. So he's asking essentially about the question about what works, and do we take that to be true? So there are lots of people who believe in homeopathy and prefer it. So what is this relationship between what works and what we take to be true?
Okay, again, a very important question which goes to the root of the pragmatist argument. Okay, remember that whenever you have a discussion with scientists about this, very often they'll say, well, you take a plane to go from one place to another, and then you are saying whether scientific knowledge is objective or not. And that's they're basically saying the moment you take a plane and you are willing to trust yourself to travel on a plane, what they're essentially saying is you are basically saying that the whatever scientific knowledge is true and that it is not disputable. It's actually a very important argument because we have to engage with it, right? And my first quick point is this. Yes, I sit on a plane and I fly in the air from one point to the other. Let's accept that it is true. the question I would like to know is, from that particular event, what can I conclude that something is absolutely true? What, in other words, what does flying in an airplane, what truths does it support? The reason I'm saying this is because, as the question pointed out, there are many people who take homeopathy. There are millions who take Ayurveda. Especially in this COVID time, I've been watching this because this is a question is of always a great interest to me on looking at alternate epistemologies. So we have people during this whole COVID pandemic. There have been thousands of people who have been taking so-called alternate medicines, including Ayurveda and so on. And there are all kinds of herbal preparations, some of which may be bogus, etc. But people are taking, people are getting well. We don't know. I mean, in India, of course, we don't know anything about anything. There's no truth, there is no reality of any kind. But the point is, if something is working for them. Just like I'm sitting on the plane and it's taking off. You are now asking me to conclude from that what exactly is true. That is the big problem. Because in medical science, that if homeopathy works, they may say it's placebo, right? But the reason what they're saying is you're not giving us a causal link. But modern science can't give you causal link for individual human bodies. It's impossible. That's why modern science is a collective science. It begins by creating classes, not individuals. Just like Newton's famous method begins by looking at different motions and classifying them under one category called motion, whether it's a motion of earth around the sun or a stone falling. It's a remarkable leap of imagination. But it's about classes, not about individuals, including individual bodies. So when there are structures like homeopathy and Ayurveda, which talks more about the individual body than a collective biological body, then it has to be understood on that level. So all I'm saying is that we cannot talk about understanding the empirical value of some of these practices without recognizing that all of them have a theory. Ayurveda creates what it does, not because they just sat and felt like it and created that particular thing. They have a complete system of practice which produces those things. So unless we understand that theoretical structure and then dispute it, criticize it and say that's absurd, etc. But we need to engage with that metaphysics of that system before we can actually, accept it or reject it.
So I think I will take one final question, and Professor Sarukkai has been very patient with the questions. And so I think there's a question from our department philosophy colleague Aditi, and it's pretty long. So I would request Aditi to unmute herself and speak, perhaps, instead of me reading it.
Actually, I would rather sort of, because Professor Sarukkai has actually dealt with the question pretty well already. Okay. So I think we should let one of the students' questions go forward. And
Okay. So there's a question by Rajdoon I saw at some point. Let me see if I can find it. Or there may be more. Let me see.
I can sort of put together one of the students' questions. I think some of them are about mathematics, actually.
Okay.
Yeah, Aditi, just one more question. So if you can select.
Right. Okay. So I think the question is about the relationship between science and mathematics, and about the independence of mathematical truths from the observer. So that's one question from Shashank. And the other question from Rashtoon is on the role of mathematics in ascertaining constructed truth in physical sciences and distinguishing what he calls its truth value from what is ascertained from philosophy. And he's mentioning Newton. Okay, I think that's clear enough.
I think we'll leave it at that.
Yeah, we can leave it at that. Yeah.
Okay. Again, there's a lot to talk about the question of mathematics in it. I think it's one of the classic, very interesting question of how philosophy can meaningfully engage with the questions of knowledge and science and truth. So there is, I'll give you a very brief thing, but written quite extensively on this. You can see two of my pieces, but one in Current Science on revisiting the unreasonable effectiveness of mathematics, which summarizes many of these points also. But the one of the questions is, what is the real relationship between mathematics and the world or the human observer, right? And why does mathematics appear to us as if it's completely independent of various other kinds of problems which empirical truths have? So my perception, I cannot trust my perception. So this leads to a very important, a turning moment in Western philosophy in trying to come to a balance between the difficulties of empirical truth or empiricism in the larger sense and the so-called strength of the rational method or the thinking or thinking through models like mathematics. And mathematics, as I said, in the Western tradition has always been associated with theology very deeply and has been a very important model for philosophy's own engagement with the idea of truth and knowledge. Which again, as I said, it doesn't happen in the Asian and African context, and that has fascinating reasons why. Okay, the point here is this. So why I'm saying all this is it is related to your thing, but I can't go too deeply into that. But the very quick point I want to make is this. What does mathematics actually do? So when I'm looking at a phenomenon in the world, what does mathematics actually do? So this goes back to an idea which seems to be something very interesting about human cognition, which is that when we experience a phenomenon, any phenomenon in the world, we seem to have the capacity to abstract something from it. That is, we take out something from it. We are able to pull that quality out of that particular phenomena, a particular object. So I'm able to abstract the color from my table, which is yellow in color. I can abstract the question of yellow from the table as if it's an independent existence of that from the table. And therefore, the color itself becomes a kind of universal, or there are various ways in which we understand that, but something which can be removed from the object in question. And mathematics arises in a very important sense through these notions of abstraction, of how I can pull out certain things away from me and the phenomenon in discussion, and therefore it allows you a completely God's eye view description of the world. But there are many accounts of mathematics today, including accounts called embodied mathematics and so on. And I would also add various Indian philosophies of mathematics. There is nothing called philosophy of mathematics in the Indian context, because Indian philosophers, even though they had very advanced notions of logic and language, both of which are very closely related to mathematics, and they also had one of the world's highest development in mathematics, which went to Europe, which created the modern scientific revolution. But yet they did not do the kind of philosophical questions of mathematics because they were not stuck with the very theologically influenced ideas of Platonism and what comes after. So I think that raises very interesting questions about how the use of mathematics to describe the world is. But as I said, if mathematical truths are independent of the world, independent of the empirical truths, then why should it matter to the description of the world at all? What is so special about it? And that's a very unresolved question, the so-called unreasonable effectiveness of mathematics. But maybe we should continue this discussion because there are a lot of many other ways of entering into it. But it's an extremely interesting question to look at.
So yeah, I think Professor Sarukkai, we'll need to have you back for another talk at some point, and because there are lots of questions and comments which we couldn't take and couldn't address. Thank you everyone for your questions and this very interesting discussion that all of these questions led to at the end. So I would like to end here and thank everyone. So thank you once more, Professor Sarukkai, for that really enriching talk and for your patience in taking all of these questions and sharing your thoughts with us. And yeah, I'd also thank our Dean of Research at the end again for facilitating this whole thing and for supporting this initiative of an online institute lecture. So with that, I think I will conclude. Thanks, Professor Sarukkai.
Yeah. Thank you, Dr. Antara. It's a great pleasure. I thank Professor Shukla and also Homeopathy. Great to see that, you people are doing some interesting stuff. Thank you.
Thank you. Good evening, everyone.